Hello and welcome to another episode of the Human in the Machine podcast, the podcast about all things HCI. As ever, I'm your host, Professor Ben Cowan. Today's episode focuses on the design of virtual humans and animals in virtual worlds. We had the pleasure of being joined by Associate Professor Rachel McDonnell from Trinity College Dublin, who is exploring the dimensions of virtual human and animal design and how this affects user perceptions. So again, this episode is in two parts, with part one focusing on Rachel's talk about the topic, and then Rachel joining me for a chat as we discuss human-like avatars, the metaverse, and the challenges researching in VR. Remember, if you like this episode, please give us a review and follow us. If you have any ideas also for episodes, questions, suggestions, discussion points, or again, if you just want to say hi, please send them to humaninthemachinepodcast@gmail.com. All that's left for me to say is sit back and enjoy.
Today I'm going to talk a bit about my research, and the title is Take a Walk on the Wild Side, Experimenting with Virtual Humans and Animals in Virtual Worlds. So I'll tell you a little bit about what that's all about now in a second. I'm just going to start off with so my own group is a computer graphics group in Trinity, and we've kind of specialized in virtual humans and motion capture, typically for computer games and visual effects, but we also do research in we've also kind of applied that research to virtual reality. So this is an example of one of the first virtual humans I ever worked with in the early 2000s, called Pt1. I named her and everything. And she wasn't very realistic, as you can see there. But I had a huge fascination from then on to kind of try to push virtual humans further into looking more like us and behaving more like us. And this has been an area that I've been researching for the last 15 years. So I guess to put that in context with now, with everyone talking about the metaverse, which is basically where we expect the internet to go towards 3D rather than 2D. So we'll all be wearing our virtual reality headsets and interacting with virtual humans in the near future, apparently. But whether this becomes a reality or not, it's really, for me, a huge fascination because, when I started working on virtual humans, the idea that we could actually motion capture somebody, their unique movements, and apply them to an avatar live in real time and interact with other avatars, it just felt like science fiction at the time. So it's a really exciting kind of time and area to be working with virtual humans in this space. There are so many ways now that I could represent myself. I don't have to look like my physical self. I can look any way that I want. So how should I represent myself? And I guess this takes me to, I will look at some of the research that we've done. Our research was mainly for virtual humans in movies and games, but actually a lot of the perceptual work that we did around character motion and appearance is very applicable to this idea of representing yourself in VR. So I'll talk a bit about that. So these are some examples of avatars I created of myself when I was in the lockdowns, which we've all forgotten about. So as you can see here, there's different levels of realism there. Obviously, you're going from kind of cartoony to more high-end realism, but you can also perhaps imagine yourself as something completely different, like an animal, for example. This is one of the things that I find fascinating about virtual reality. It's not like, can I create a perfect replica of myself either? It's, can I give myself superhuman properties, or become an animal, or do something strange? There's endless possibilities with what you can do with computer graphics. So there could be a question of why bother with realism? Why not go for something a bit unrealistic? So just getting back to appearance. So if we start with appearance, and I'll also look at motion. I'm not going to look at voice today because we're assuming that the avatar's voice will be coming from the human themselves. So appearance and motion are two things that we have kind of control over. So you've often heard this phrase, don't judge a book by its cover. And that's usually is a good phrase to go by in life. But there's been some psychology studies showing that the first impressions formed of people happen in a fraction of a second and with limited accuracy. So not necessarily accurate, but these impressions do form. And they can have critical social consequences. So I think this idea is very interesting from the point of view of virtual reality and how you decide to represent yourself. So just to look a little further into some of those psychology studies. So for example, we'll just take an example in research in psychology has shown that some personality traits are strongly influenced by certain specific facial traits. So the facial width to height ratio. So if you see, I think I have a little red square here, the ratio of the width to the height of the face has been shown to be highly correlated with ratings of dominance, aggressiveness, honesty, and appeal. And then also eyes are another area. So larger eyes and smaller eyes can be associated very, very, very strongly with honesty and dominance. And our brains seem to have evolved to process these features quickly and draw immediate conclusions about them, such as whether a person is a threat or not. And I get this is why it's the process is deeply rooted in evolution. So it's automatic and it's at a subconscious level. One of our studies looked at whether or not when you were looking at yourself, say like this in a Zoom call, and you applied a filter to your own face, do you start judging yourself as more dominant or aggressive or things like that? So we actually did find that all of these previous psychology study results also applied to your own face. So this could have interesting consequences for if you were just to apply a filter of some sort to change the width to height ratio of your face. Would you be more convincing in an argument, for example? And that's something, of course, that we're looking at the moment. This was actually, I looked at it also from the point of view of primates to see, does it have, how far back or how much of an evolutionary link there is. So I'm just going to ask you here, and I know you can't really answer me, but maybe you can answer yourself, and I'll tell you the answer in a second. Which of these chimps are high on dominance, do you think? Well, hopefully all of you have an answer anyway, whether it's right or not. Well, I don't know if there's even a right answer. Well, anyway, this one was the one I would have certainly said definitely higher on dominance. But there were some studies that looked at this and found that indeed the ratings of the faces were similar to the faces of humans in terms of the width to height ratio, in terms of dominance, and also the personalities of the chimps matched up with the rating. So there's definitely something evolutionary going on there. So this was something that was very interesting for us in terms of virtual humans, because of course in VR you can change your appearance to whatever you want. So we wanted to see, did these same laws apply across virtual humans? And in general, when the appearance of the character has realistic proportions, the rules apply, they're the same. Whereas we have more abstract characters that have kind of more cartoony representation, there's some of the effects are the same, but some differ. So for example, in the case of the study on top is our study, and the one on the bottom is by Songhan and Luxman. But we both found that wider faces were judged to be less dominant in the case of these kind of abstract characters, whereas narrow faces were more dominant, which was the opposite to what you had in real faces. So I'm going to ask some more questions. So in these characters, you can see they're extremely abstract. So they don't even have a nose or mouth. But could you make a judgment about trustworthiness on these characters? Would you be able to say whether one of them looked more trustworthy or the other? I'll give you a second to have a think about it. Which one? So the one on the left is the most trustworthy, and so we did all the studies on this, and again they did match up to the rules. Again, these two, what about 3 and 4? Which one is the most aggressive looking? So 3 most aggressive and 4 as the least aggressive. So actually we went further with this study, and we ran an experiment where participants interact with these virtual abstract characters. And it was this kind of a dilemma situation where it's a moral dilemma. You have to make a decision to sacrifice a life for the sake of saving others. And what our key finding there was that if you used an aggressive looking character in the telling you about the moral dilemma, it yielded more utilitarian responses. So in that case, what would be considered a more violent response would be sacrificing a life for a greater good. So I mean, I think one of the things that we found interesting from this study was the fact that, of course, care should be taken choosing character if you're going to be presenting a moral dilemma. But you know, the fact that just the appearance of the character can have an effect on your behavior. And similarly, there's been research in the VR community showing that if you embody a virtual avatar with certain properties, you actually start to take on those properties yourself. So the examples in the literature are things like if you embody a taller character, your behavior starts becoming more confident, or there's other examples as well. But yeah, there was one nice paper with a Joker and Superman, and they found that if the participants were embodying the Joker, being aggressive towards everyone, whereas if they were embodying a Superman character, they took on the role of the character. So again, the appearance is very important in virtual reality for all sorts of different reasons. There's this idea of the uncanny valley, which is something you may or may not have heard of. It's based on a theory in robotics that the more realistic you try to make a virtual or a robot, but it also kind of translates to a virtual character, it starts to become more appealing to you because it's more human-like. But then it reaches a certain point where it's trying to replicate a real human, and it might give you a kind of a negative response. So I don't know, some of the more recent computer games and things like that, you can see some very, what we call uncanny kind of characters that looked just a little bit wrong or something. So we did a lot of experiments on the uncanny valley, looking at the effect of realism and just trying to drill down exactly, because it's really a theory, it's not proven. We're trying to drill down the aspects of a virtual character that you have to change to call these give these kind of negative effects. So we ran tons and tons of studies on this stuff, looking at things like material and shape, and changing the material and the shape, and trying to identify what are the combinations that are most appealing and least appealing. Just generally, some of the results we found were things like material. So again, virtual characters, one of the nice aspects of them is with computer graphics, you can change literally anything you want about the appearance, even down to, you know, it could have the exact same shape, but you have a different material applied to it. So this shows some examples here. Or you could even change the lighting or the hair. Or there's just so many options with a virtual character that actually trying to drill down which of them has an effect on user behavior can be quite a daunting task. So in this case, yeah, we found that the material was the main predictor of things like appeal, attractiveness, and even eeriness. And the shape of the character's face was the main predictor of realism. So if you wanted a more realistic character, you had to make sure that it had realistic proportions. And we also found that in the middle, kind of hard to categorize characters were judged as more eerie. So if you had the shape of a cartoon, but the material of a realistic character, that kind of combination was where we found the most eerie. Well, eerie is what we kind of use to define the uncanny valley, or kind of a creepy effect. Okay, so face ownership then is something that is important when you're embodying a virtual human. So if you want to take on the body of a virtual human, so there's many studies, again, back at early VR research, and even in psychology, the rubber hand illusion, if you haven't heard of it, look it up. Or the Pinocchio illusion is something you could try yourselves. That's something, maybe look up that. But this is the idea that the brain is plastic, has plasticity, and can take on a virtual or even a rubber hand and think that it's its own. So there are different circumstances in which that has to happen. And one of the most important ones for virtual reality is visuomotor synchrony. So that means when I move my hand, the virtual body should move its hand as well. And similarly, if I turn my head, like all of these motor changes that I'm having should be happening to my virtual character. And once they are, then I feel that that body is mine. And then if, for example, you give a threat to the virtual body, you come at it with a sword or something like that, and the participant will actually feel, that their real body is threatened. So face ownership is something that doesn't get as much attention, but it's something that we've looked at quite a bit, trying to determine if when you embody a virtual character like this, can you really feel as though that virtual face is your face? And generally you can. This is one of our studies recently. I'll just show an example. So this face is being the participant on the left's face is being tracked, and it's being applied to this virtual character, and it's as if he was looking in a mirror.
Pizza? To put like pineapple on my pizza. I don't mind it. I wouldn't go out of my way to put it on my pizza though.
We asked a lot of ridiculous questions. And here are some examples in that study where we applied the movements live to different he's straightening out of shape there on the left, but we applied different ages of characters to see if that affected your level of in face. So if do I only feel as though it's my face if it's a similar age to me? If it's an older character, maybe I don't feel that. Race change is also possible, the level of ownership of a body or a face. So really we can make our body or face whatever we want it to be in VR, and actually we will still feel like that it belongs to us, and that we can use that character as ourselves. Clothing is another aspect that we had a brief look at last year. We wanted to see if people in groups were affected by the clothing that they were wearing. There are reasons for doing this, but I don't have a huge amount of time to get into them. But for example, here you can see that on the left, there's a group of participants taking part in an experiment. So these are all in VR and having an interaction with the group in VR. And for example, when you're in VR, if you change the clothing that you're wearing, does it actually, because in real life, that does have an effect on you. If you have, if you're wearing a suit or something like that, you might feel more business-like and able to make decisions better, for example. We found no effect in this case of the clothing. So again, there could be other reasons for that, but one of the nice things we found about this was the interactions in VR for groups. People felt like leaders more than they did in real life, so that was a nice kind of side effect of doing this experiment in VR. So that's clothing. So then motion then is the other thing. So that's kind of appearance. So motion then, I'm going to just quickly go back to some early experiments done in the 1970s. I just want to show you a little clip here, and if you can try and think about what you think is going on in this clip, if you can see it. It's just a dot moving across the screen, right? Some people think it looks like a little bunny, or they don't really know what it is. So now if I add more dots to that, let's see if it starts to become clearer what's going on. So with those other two dots, can you kind of figure out what that is? So if you haven't noticed that's a leg moving across the scene. Here there's a little dot moving across the screen, but if we add more dots to that, you can clearly see that it's an arm moving across the scene. So the purpose of this is to highlight the fact that humans are really good at understanding patterns in the movement of other humans. This is called biological motion, and it's really innate. It's something that we can do really at a very, very young age. So we can associate those just even that small little information together, and we can understand that it's a human body movement. And it's related to the fact that we're so used to seeing humans moving. So for example, if you saw a bunch of dots like this, you will start to make patterns in your brain with regard to relationships between them, even though they're random. But it's nothing like something like this where you can really see the two. And even when they cross over each other, your ability to know that it's a person and a moving person remains. So what is this interesting for virtual reality? So my interest in this was motion capture, because motion capture is where you apply markers to the main joints of the body, and you capture the movement of people. And this is something that you have to do in virtual reality if you want to embody a character. So if you want to be able to have that visuomotor synchrony, you want every joint of the body that you're moving to be moving the same as the virtual character. So motion, this is like almost early motion capture. How they did it in the 70s was they actually put light bulbs on the major joints of the participants and put them in a black room and did that. But nowadays we just use motion capture. We can get these similar patterns. So people were very interested still. They continued research on biological motion for years after that initial study. And they found things like you can determine people's gender from their motion. You can determine their identity. Everyone even has a kind of unique way of walking. And their emotional state, their state of health, and even personality traits. They can all be determined from just looking at these point light displays. A recent study done by researchers in Berkeley, this isn't my own work, but I think it's really interesting, was where they collected data in VR from, I don't know if anyone's played Beat Saber. It's this game where you just basically, like, it's like a lightsaber and you're whacking things. But anyway, they gathered information from 50,000 users on Beat Saber, and were able to use machine learning to identify the patterns of motion and identify those an individual with a very, very high level of accuracy. So if the graph here shows if you have 100 seconds of data of the user, you're way over 97% or 98% accuracy in identifying that very same person. So I think hopefully this speaks to the idea of, like, when you're in VR, all of the movements that you're doing have a unique fingerprint for you. So not only identifying who you are, it could be identifying medical conditions, all these kind of things. And again, that's an ethical kind of question around should we be handing out our motion that well, but that's for another day's debate. Okay, so I kind of discussed a little bit about this idea of body ownership before, where you take on the feeling. And there's another way of doing it with visio-tactile stimulation, which is where if you see in the image in the top there, there's a rubber hand, and the experimenter is simultaneously rubbing what is that, like a paintbrush along both, and after a while the participant thinks that the rubber hand is their own. Body ownership is something that we're looking at a little bit. Just a side note with my postdoc at the moment. So we're looking at things, for example, where if you look down and your virtual body is moving, but your own body isn't moving, how does that affect things like your brain response and your muscle response? And interestingly, she has found previously that the heart rate increase. So for example, if you look at your body exercising and you're not exercising, you're just sitting on a chair, it actually increases your heart rate, changes your brain activation, and has positive effects for things like concentration, which you would normally get from exercise. And also more recently, we've done some work that shows that your muscles are actually activating when you in a first person view see your virtual body moving. So there's a lot going on when you're in VR. It's you really do take on as if you feel that this body is your own. So it can affect you in all sorts of ways. Okay, so finally, I just want to get quickly onto my last point, which is about the animal embodiment. So this is kind of a bit more for the fun element, but there's lots of actual challenging computer graphics research in this area, which is why we're kind of looking at it. So animal embodiment in previous work has been mainly kind of humanoid animals or unrealistic with unrealistic kind of motion. So there are many challenges with regard to embodying an animal, and it's mainly related to the morphology differences. So the difference in the shape of the body, there's significant differences which make it very challenging to have this visio-motor synchrony. So when I move my arm, what should be moving if I'm embodying a snail or something? So it's this idea of trying to find out how we could do this effectively. So here's just examples of some early tests we were doing. This is an example where the walker is in front, and we've got the same legs on the, because again, if you had a quadruped, for example, you know, how do you actually map your legs and arms onto a quadruped's legs? So this is some study. There's lots of work in the computer graphics and animation using things like neural networks and procedural animation to try to do this kind of mapping. We took the approach of motion capturing a lovely dog and getting all their unique motion fingerprint from the motion, and learning that through machine learning to try to learn the unique motion of a dog. Input the human motion and convert it to dog motion. So here's an example of our system working. So on the top right there, you see my student Donal walking around. On the bottom left, you see from a third person's perspective what the dog is doing. And on the bottom right, you see the first person perspective. So that's what Donal is seeing when he's looking at a mirror of himself being a dog, basically. So yeah, so again, the idea is to try to have realistic dog motion, but being driven by a human. And yeah, so the results of our paper there, we called it NeuroDog, was that people were able to feel body ownership over this dog. And the higher the level of accuracy of the motion, the higher the level of embodiment. So people did really feel that they owned the dog's body. We also tried oral feedback, where we had the feedback of the fur on the animal. I'll show you an example video of that because it's kind of funny. So here's an example of of where we're trying to embody a dog while brushing on the fur. So you could both hear the feedback of the fur sound, and you could also feel the brush going down your back. So in that case, we had video, mainly tactile, and then with audio feedback. Yeah, you can kind of hear the sound of a brush, and that was just tactile as well. So we did loads of different combinations. In that study, we found that tactile feedback was more important for things like fur ownership, and feeling that the body had changed than things like audio feedback. But we're going to look into that in more detail. All right, so why animals? This is a study that we're doing at the moment with the Lear Academy, which is where they usually use animal embodiment as a study for actor training, to feel a sense of it's really good for training actors to have a change in their body and be aware of their movements and things like that. So we're working with them at the moment to apply their motions real time, where they're moving and their animal, they can see their animal, so to try to enhance their performances and their feeling of embodiment. So this one is an example of an eagle. Actually, we have 15 of them coming to our lab tomorrow to embody various different animals. So that should be interesting. There's a number of open questions, which I'm sure we'll get to in the discussion. Playing the different role of different avatars. What are the endless possibilities in VR for your appearance and your motion? And the importance of various aspects. There are some different papers, courses and things, if you're interested to look a bit further on this. We've summarized a lot of the research in different papers. And just a thank you to the students whose work I presented here. But and thanks everyone for listening.
Again, thanks so much to Rachel for giving us all the insight into the world of virtual agent design. So next time I make an avatar, I might go for something a little bit more on the wild side, just to test things out. Again, don't forget to review and follow us, and if you want to get in contact with us, you can get in contact by emailing us at humaninthemachinepodcast@gmail.com. And all that's left for me to say is I've been Ben Cowan. Stay curious and don't let the machines get you down. Until next time.